In this video, we are going to talk about reference angles. Reference angles are very important because they can determine the properties of any angle by just looking at one reference angle. It also depends where the actual angle is that we are looking for, say angle theta. So let's talk about the definition of a reference angle. It says, let theta denote an angle that lies in a quadrant. The acute angle formed by the terminal side of theta and the axis is called a reference angle for theta. And we are going to call that, the symbol for that angle is going to be alpha. Notice that we can get the reference angles for, in our examples, for 120 degrees, minus 30 degrees, 225 degrees. In terms of degrees, in terms of radians, we have minus pi over 6, 4 pi over 3, and 7 pi over 3. These are angles, and what we are going to be doing is to determine the reference angles for each one of these given angles. We will see in a minute the usefulness of reference angles. So let's talk about the theory. So a reference angle alpha. Let's give an example here. Let's say that we have an angle alpha, and it lies in a quadrant. So let's assume that this angle theta lies in a quadrant. Well, notice that this is called the terminal side of angle alpha, and this is called the x-axis. So for this given angle, we have a reference angle, and that reference angle is the acute angle formed by the terminal side of alpha, of theta, and the x-axis. This is the x-axis right here. So for this angle, the reference angle is also theta. We're going to call it alpha. Let's assume that we have theta in the second quadrant. So that would be angle theta. What would be the reference angle? Well, if we look at the definition, is the acute angle formed by the terminal side of theta. Remember, this is the terminal side, and the x-axis. This is the x-axis right here. So for this angle theta, the reference angle is this angle right here. That would be alpha. Let's say that we have another angle. Let's erase this a little bit here. Let's say that we have another angle that falls in the third quadrant. So this would be the angle theta right here. Well, what would be the reference angle? Well, the reference angle is this angle right here. It's the angle that it makes with the terminal side of the angle theta and the x-axis. So that would be the reference angle. And let's assume that we have the last case in which we have what? We have the angle in the angle theta in the fourth quadrant. What would be the reference angle? Well, you guessed it. It is this angle. It's the angle that it makes with the terminal side and the x-axis. So that angle right here is your reference angle. Let's take a look at several examples. Let's assume that we have 120 degrees. What is the reference angle for 120 degrees? Well, let's take a look. Let's say that we have our angle 120 degrees. Well, 120 degrees is in the second quadrant, right? All the way here. So this angle right here from here to here is 120 degrees. So that's the angle theta. What would be the reference angle? Well, we know that is the angle that it makes the terminal side with the x-axis. So this angle is the reference angle. So what is the measurement of that angle? Well, we know that is from here to here is 180 degrees. That's theta all the way up to here. And from here to here, what's that measurement? That measurement is equal to 60 degrees. So the angle is 120 and the reference angle is 60 degrees. Well, what's the usefulness of having a reference angle? Well, we know that the reference angle, if you know the reference angle, you know the properties of 120. So we don't need to memorize what the properties for every angle. All we need to know is the properties of 60 degrees. In other words, if we have the say we want to find the sine of 120 degrees, it is equivalent to the sine of 60 degrees with two conditions. We need to be careful about the sine here, and we need to be careful about the reference, the magnitude of the reference angle. So let's take a look. We know what the sine of 60 is, right? Well, the sine of 60 is equal to square root of 3 over 2. However, what do we know about the convention in this? What's the sign is it positive or negative in the second quadrant? Because the reference angle is in the second quadrant, isn't it? Therefore, we know that, say, for the sine, of any angle in the second quadrant is going to be positive here, negative in the third quadrant, and negative in the fourth quadrant. So notice that the reference angle is in the second quadrant, so the sign will be positive. Let's take a look at the cosine of 120. Well, it'll also be equal to the cosine of 60. Well, but we need to be careful about the sign here, wouldn't we? Well, we know that the cosine of 60 is equal to 1/2. But what's the sign? Well, what is the sign convention? The sign convention is the cosine of theta the cosine is positive here, and here is negative anywhere else. Therefore, we know that the cosine is in the second quadrant and is going to be negative. So we know that this is going to be minus 1/2. How about the tangent of 120? Well, we know that the tangent of 120 is going to be equal to the tangent of 60. Except that we need to be careful about the sign here, right? Well, what would be the convention, sign convention for the tangent of the angle in the second quadrant? Well, we know that the tangent is positive here, negative here, positive here, and negative here. Therefore, if we are looking at the tangent of 60 degrees, which is equal to the tangent of 120, but what happens? We are looking at once again, the second quadrant. In the second quadrant, the tangent is negative. So it is the tangent of 120 is the same thing as the tangent of 60, which is equal to square root of 3. But it's going to be negative. Let's take a look at another example. Let's take a look at the tangent of the tangent, the sine, and the cosine of minus 30. Once again, what do we have? We have, like in the quadrants, we have minus 30 will be this angle right here, right? So the theta is going to be equal to minus 30 degrees. So what would be the reference angle? So we know that the reference angle has to be the angle that it makes in that quadrant with the terminal side and the x-axis. So that angle right here is also the reference angle. So it is 30 degrees. So what are the properties of 30 degrees? Well, we know that if we want to find what the sine of minus 30 degrees is, all we need to do is to take a look at the sine of 30. But what would be the sine? We just look at the conventions, didn't we? For the sine of the cosine for the tangent. We look at the conventions for the sine. The sine is positive here, here, and negative in the third and fourth. The cosine is going to be positive here, and negative here. And the tangent is going to be positive here and here, negative in the second and fourth quadrant. So let's take a look. Well, the sine of negative 30 degrees or minus 30 degrees is going to be the same thing as the sine of 30. What's the sine of 30? 1/2. All we need to look is take care of where is that angle, in what quadrant. Notice it's in the fourth quadrant. So the sine, we look at the fourth quadrant, that's going to be negative 1/2. How about the cosine of minus 30? Well, that's going to be equal to the cosine of 30 as well, which is square root of 3 over 2. Except, what is the sine? Well, let's take a look. Fourth quadrant, that's going to be positive, so it's going to be positive 3 over 2. How about the tangent? Tangent of minus 30 degrees is going to be equal to the tangent of 30 degrees. And let's take a look at the sine. We are in the fourth quadrant. Therefore, the tangent is going to be negative at that point. What is the tangent of 30? Well, the tangent of 30 is equal to minus square root of 3 over 3. And therefore, actually square root of 3 over 3, but the tangent is negative in the fourth quadrant. Let's take a look at another example. 225. Let's take a look at 225. Where is 225? Well, let's see. That is 225 will be at this point. So theta is 225 degrees. What's the reference angle? It would be this one, wouldn't it? That is 220. The reference angle would be that one. Theta, and the reference angle would be, well, 225 minus 180, that would be 45 degrees, wouldn't it? Okay, so what do we know about 225? Well, we want to find what's the sine of 225 degrees. Do we need to memorize the sine and cosine and tangent of 225? No. All we need to know is that the sine of 225 is equal to the sine of 45 degrees. We just have to be careful about the sign. Once again, what's the convention? The sine of theta, cosine of theta, and tangent of theta. Let's take a look. We know that sine is positive here and negative here. Cosine is positive here and here, negative here. And the tangent is positive here and here, and negative in those other places. So, we know that the sine is going to be in the third quadrant. Well, let's take a look. The sine is negative at that point, so it's going to be negative. But what is the sine of 45 degrees? Well, we know this is going to be square root of 2 over 2. What about the cosine of 225 degrees? It's going to be equal to the cosine of 45 degrees. It's going to be equal to square root of 2 over 2. We are in the third quadrant, and the cosine is negative at that point, so it's also negative. About the tangent of 225 degrees? It's going to be equal to the tangent of the reference angle, which is 45 degrees. But what's the sine? Well, we know that the tangent in that quadrant is going to be positive, so it's going to be a positive. What's the tangent of 45? We know that it's going to be 1, and so forth. Okay, getting the idea? Let's continue with the next example. Let's talk about radians now. Talk about radians. Well, in this case, what do we have? We have that this is going to be minus pi over 6. Theta is equal to minus pi over 6. Well, what's the reference angle? The reference angle is this angle, isn't it? As well. But that angle is equal to pi over 6. And we know that then conventions, sine, theta, cosine of theta, and the tangent of theta. Sine positive here and here, negative. Cosine positive here and here, and the tangent positive here and here. So that is actually the reference angle. So the tangent of minus pi over 6 is actually equal to, let's start off with the sine. Start off with the sine first. Well, the sine would be equal to the sine of the reference angle, pi over 6. And what is the convention? Well, let's take a look. It is in the fourth quadrant, isn't it? And it's going to be negative. So the sine of minus pi over 6 is the same thing as the sine of pi over 6. But since we are in the fourth quadrant, that's going to be negative. We all know that pi over 6 is the same thing as 30 degrees, which we already did. So it's going to be equal to 1/2. So the cosine of minus pi over 6 is going to be equal to the cosine of pi over 6. Once again, we are in the fourth quadrant, don't we? Or aren't we? So that's going to be positive. Cosine of pi over 6. What's the cosine of pi over 6? It's going to be positive square root of 3 over 2. How about the tangent of minus pi over 6? Well, we are over here, so that's going to be minus tangent of pi over 6, which is going to be equal to minus square root of 3 over 3. Let's go to the next example. Excuse me. Four pi over 3. Take a look, pause the video, go ahead, solve the problem, and let's see if we have the same answer. Where is 4 pi over 3? Well, we have 4 pi over 3 right over here. So that's going to be all the way up to here. So remember that this is going to be pi over 3 here, another pi over 3 here, another pi over 3 here, and another pi over 3. So we have 1, 2, 3, 4 pi over 3. So what would be the reference angle? So the reference angle would be that angle right here, wouldn't it? So that would be, our alpha is actually pi over 3. So the properties of 4 pi over 3 are the same as pi over 3, except we need to be careful with what? The sign, as usual. Conventions. We should be able to memorize this so that we don't have to look it up every time we work on a reference angle problem. But let's have it just in case. Remember, sines are positive here and here, cosines positive here and here, and the tangent is positive here and here. Obviously, negative everywhere else. So, what would be the sign of 4 pi over 3? Same thing as sine of pi over 3. So, instead of using theta, we use the reference angle to find the properties of sine of pi of theta, 4 pi over 3. Well, the sign is, where are we? We are in the third quadrant. We are here in the third quadrant. So the sign is negative at that point. But what is the sign of pi over 3? Well, we know very well that that's going to be square root of 3 over 2. But negative. How about the cosine of 4 pi over 3? It's going to be equal to the cosine of pi over 3, and it's going to be equal to 1/2. Well, what is the sine? Once again, we are here. It's going to be negative. About the tangent, same thing all over the place. So that's going to be equal to the tangent of pi over 3. Is it going to be positive or negative? It's going to be positive. So we know that the tangent of pi over 3 is going to be equal to square root of 3. Why? Because we are in the third quadrant. Let's go to our last example. Locate where 7 pi over 3 is. Well, we have that's pi over 3. We have another pi over 3. Another pi over 3. Another pi over 3. Another pi over 3. And another pi over 3. We are looking for 7 pi's over 3. So let's start counting. That's 1, 2, 3, 4, 5, 6, and 7. So theta is going to be 7 pi over 3. We are in the first quadrant, aren't we? What's the reference angle? Well, the reference angle is the angle that it makes the terminal side with the x-axis. So this would be alpha, which is equal to pi over 3. Where are we? We are in the first quadrant, aren't we? What's the sign conversion? We should know this thing by now. Let's write it as reference though. It's positive here and here. Positive here and here for the cosine. And positive here and here. So let's take a look. The sine of 7 pi over 3 is going to be equal to the sine of pi over 3. What do we know? Well, we're in the first quadrant, so it's going to be positive. What's the sine of pi over 3? So it's going to